Lesson 23, quadratic equations. So on this first slide, what we're talking about is the fact that we are dealing with some quadratics. We've seen quadratics before in Algebra 1, so we just wanted to go back to, in Lesson 22, we learned about complex numbers. So I wanted to show a graph with no real solutions. Back in the past, that's what you've said. But now we know these are actually complex solutions, and that happens when your discriminant, which is equal to b squared minus 4ac, is less than 0. So discriminant is part of the quadratic equation, and if you think about it, if that's a negative number under a radical, well, then you get complex numbers. You've also seen in this class before that we've talked about double roots when you have solutions. So on the right graph, there's a quadratic that has a double root happening at positive 3. This happens again when the discriminant b squared minus 4ac equals 0. Those are things that are going to come up in our future, but since we're in a new unit all about quadratics, I thought I'd start off with that. Things you need to know. Quadratic equations come in the standard form of f of x is equal to ax squared plus bx plus c. If we set that equation equal to 0, it means you need to find the x values when the y value is 0. There are multiple directions that could be given to you in a problem, such as solve, find the zeros, find the x-intercepts, find the solutions, and find the roots. So we're going to do our first example. It's method 1 using the square root method. So there's multiple methods of solving quadratics. One of them is known as the square root method. When you use the square root method is when the middle term, the bx term, doesn't exist. It's missing. So in this example, we have 2x squared plus 6 equals 150. In this case, you want to isolate the squared term. Well, in this case, it's just x squared, so we're going to move the 6 over by subtracting. We're going to get 2x squared is equal to 144. We're going to divide both sides by 2, get x squared is equal to 72. And then from here, we're going to get x is equal to the plus or minus the square root of 72. Now, we need to remember that 72 is comprised of 36 times 2, so when we square root that, our final answer that we're going to get is the plus or minus of 6 square root of 2. And you're done. Second example, you have x squared plus 5 equals negative 4. Again, there's no middle bx term, so we're not going to use any other method other than isolating the squared term and then square rooting both sides. So we're going to say x squared equals minus 5 from both sides. You get negative 9. From here, when you square root both sides, you're going to get x is equal to the plus or minus the square root of negative 9. Remember, the square root of negative 1 is equal to I. So now I can say that x is equal to plus or minus 3i. Leave your answer in solution set notation and move on. The next example I give you is x divided by 4 minus 1 quantity squared equals 25. This is no different than the last one. You have some squared term. So again, is this squared term, the whole term of this, is this isolated? Is there anything adding or subtracting to it? No, not around it. Yes, inside of it, but that's okay. So I'm going to square root both sides. When I do, I'm left with x divided by 4 minus 1 is equal to the plus or minus the square root of 25, which is 5. From there, I'm going to create two cases, similar to solving absolute values. I'm going to say x divided by 4 minus 1 is equal to 5, and x divided by 4 minus 1 is equal to negative 5. Then you solve for x appropriately. So on the left equation, we have x divided by 4 is equal to 6. Multiply both sides by 4, x is equal to 24. On the right equation, you're going to add 1 to both sides. So x divided by 4 is equal to negative 4. Multiply both sides by 4, x is equal to negative 16. Final answer goes in solution set notation. I like to put the negative number first, then the positive, and then we're done. Next, we're going to enter fraction review. This is just review of how do you square fractions. So if I were to give you a b value of 3 and I asked you to find b divided by 2 squared, well, you'd plug in 3 for b and then you'd square it. Now squared means that I'm going to take whatever I see and multiply it by itself. When I multiply fractions, things that I need to remember is it's going to be the top times the top, the bottom times the bottom. So I have 3 times 3 is 9, 2 times 2 is 4, which means that 3 over 2 squared is 9/4. Then we try the second example. Again, I have b is equal to -7, and I'm asking you to find b divided by 2 quantity squared. So we're going to take -7, divide that by 2, square it. If you don't need to show the step of repeating the fraction, don't do it. You can also think of squares like this. You have -7 quantity squared divided by 2 quantity squared. That's applying your exponent properties. And you got something like 49/4. These are just things you need to know for the future lesson of today. So there's some good review of fractions. We're going to learn a second method of how to solve a quadratic. So the first method was solved by square root. You use that when the b term is missing. A second method that we're going to teach today is called completing the square. To understand this method, you need to recall the pattern of squaring a binomial. So if I have x plus y quantity squared, I need to remember that this pattern is x squared plus 2xy plus y squared. This is called a perfect square trinomial. Again, I abbreviate this as a PST, a perfect square trinomial. Today, what we're going to do is we're going to figure out how to make this process work backwards. So we're trying to figure out the y squared term. So let's look at some examples. If I were to ask you to complete the square, not solve by completing, we're not there yet, but just complete the square, what I'm asking you to do is think about the fact that that pattern we just did says that this middle term is 2 times the x times the y term. This guy is y squared. So to solve for y, we would take the b term, which is 12. Ignore the x. You don't need the x because there's no x in the last term. It's just y squared. So we're going to say 12. We're going to divide that by 2, and then we're going to square it. And that number becomes 6 times 6, which is 36. And cool, that is now our perfect square trinomial. To factor this is going to be x, y, and then whatever symbol is in the middle goes here. So this middle symbol is actually a plus for this example, so this one's going to be a plus. So when we factor this trinomial, we're going to get x plus 6 quantity squared. Now, down on this next example, I'm going to do it like this. -10 divided by 2 squared. I'm going to simplify that to say -5 squared. When I square -5, I'm going to get a positive 25. And then over on this other factor, like how does this factor, the -5 is just going to come over here. So we have x minus 5 quantity squared is the factor of that. Next example. Say I give you k squared minus 3k plus blank equals something squared. Well, what we want to do is, again, take this b value, -3, divide it by 2, and square it. This is why I did some fraction review of squaring fractions. So we're going to take -3, multiply by -3, you get 9, and take 2 to multiply it by 2, and you get 4. So we're going to add 9/4. When we factor that trinomial, it would be k minus 3/2 quantity squared. Then we do the next example, x squared minus 15x plus something equals a factor. Well, we're going to divide -15 by 2, and we're going to square it. So when you square -15, you get 225. When you square 2, you get 4, and then this factors to x minus 15/2. I'm going to add a problem in here, so bear with me while I write it with you. If on an exam there were a question that says, what number would be added to the expression on both sides. It's actually an equation. Let me go back a little bit. The equation on both sides to complete the square. What number would be added to both sides of the equation to complete the square? Given that we have the equation 2x squared minus 12x equals 0. So what they're asking is, I need to think of it like this. 2x squared minus 12x plus what number equals plus what number? That's the question. That's what it said. So to find out the number, the pink underlined number, first we need to remember how to complete the square. If I go back in a few slides, notice all of these examples, the a value of my x squared term is 1. That's not a coinkydink, that is a requirement. So I have to make this say 1x squared. So what I'm going to do is factor out a 2. So I say 2 times x squared minus 6x plus blank equals, and on the right side I have to think, well, if I factored a 2 out on the left, I have to do that on the right, because that's what math says. Whatever you do to one side, you do to the other side to make it mathematical. So from here, we're going to do our completing the square method, which says you take that b term, negative 6, divide it by 2, square it. So we get negative 3 squared, which is 9 and 9. Now the question that our test might ask us is, what number goes in the pink blank? Not what number did I just write? So be cautious, reread your question. What number would be added to the equation that I gave you originally? Well, that would be 2 times 9, in this case 18 on both of those blanks. So we would want to pick the answer of 18, not 9, because we want to do 2 times 9, which is 18. Okay, now let's do some solve by completing the square. So when we're solving, we're finding the x values that make the y value equal to 0. So the first step in solving by completing the square is set your equation equal to 0. Remember, we want the ax squared term to be 1. So I'm going to move everything on the right side to the left side. We're going to call that x squared plus 6x minus 11 is equal to 0. The first question you want to ask, is the trinomial a perfect squared trinomial? Sadly, 11 is only divisible by 11 and 1, so no, it's not a perfect square trinomial. So what we want to do is complete the square. We're going to set it up like x squared plus 6x plus blank equals, I'm going to move the 11 over to the other side so I can kind of ignore it, and then put a plus blank over there, because whatever I do to one side, I do to the other side. Then I'm going to half the b term, so 6 over 2 squared, which remember is 3 squared. I'm going to put that number in my blanks. Both blanks get that number, so I would call that 9 and 9. Now, remember when we said the trinomial, well, now can you factor that trinomial? The left side would factor to x plus 3 quantity squared, and that's going to equal 11 plus 9, which is 20. Look at this, looks like a solve by square root method now, so we want to square root both sides. We have x plus 3 is equal to the plus or minus the square root of 20. And then from there, x equals negative 3 plus or minus. Now, root 20 can be simplified to 4 times 5, so we have 2 root 5. Your final answer would be negative 3 plus or minus 2 root 5. Okay, we have 2 more examples. 1, solve by completing the square. Again, our goal is to remember that when we complete the square, the a value must be equal to 1. So this is what the orange part says. The a value must equal 1 to complete the square. I was a little lazy, didn't want to write square, so I just drew 1. When thinking of that, I also want to understand that the c term, in this case negative 11, can be ignored if I put it on the other side and kind of just ignore it. So I'm going to start by doing that. We have 4x squared plus 4x equals 11. First step. Then I want to make the a value of the left-hand side 1. So to do that, I'm going to factor a 4 out. I'm not going to divide it. Don't say divide, but instead factor. I'm going to factor a 4 out. Now, I have 11. Remember, I added this plus blank and this 4 times. So I need to, on the right-hand side of my equation, do 4 times a blank. If I don't do that, I'm not making an equivalent equation. So I want to make sure on the left side I have 4 times that plus blank, and on the right side 4 times that plus blank. From here, we do that cool thing where we take the b value, which in this case is 1, divided by 2, square it. That's going to give us 1/4 on either of these blanks. I'm going to then factor the trinomial on the left-hand side. So we have 4 times x plus 1/2 squared equals, and on the right-hand side, well, 4 times 1/4 cancels to 1, and you're left with 12. From here, you're going to divide both sides by 4 because we have to isolate the squared term. Notice 4 is multiplying, so we're going to divide both sides by 4. We have x plus 1/2 squared equals 3. Then we square root both sides. X plus 1/2 is equal to the plus or minus the square root of 3. And from there, get x by itself. So x is equal to negative 1/2 plus or minus square root of 3. Final answer, negative 1/2 plus or minus the square root of 3. And you're done. Last example I give you is 7x squared minus 14x plus 8 equals 0. Again, in this case, you want to ask yourself, when completing the square, can that c term, can I ignore it? Yes, I can. Move it to the other side. And then number 2, is the a value equal to 1? In this case, no, it's equal to 7, so I can't ignore it. I'm going to have to factor it out, but I'll do that after I move the 8. First step, we have 7x squared minus 14x equals negative 8. From here, the left side needs to be factored. I need to take a 7 out of both the first and second term because the first term has a 7 in it. So 7x squared minus 2x plus blank equals negative 8 plus, and I can't just write a blank because remember I have a 7 on the outside of the original statement on the left. 7 and blank. 7 and blank. Got to make sure they match on both sides. From here, we're going to take half this b term, so we take negative 2 divided by 2 squared, and that's going to give us the value of 1. From there, we're going to factor the trinomial, so we have 7 times x minus 1 squared equals, in this case, 7 times 1 is 7, but if you minus 8 from it, you're left with negative 1. Again, we have a multiplier on this factor of x minus 1 squared, so we need to divide both sides by 7. We're left with x minus 1 squared is equal to negative 1 over 7. From here, we need to square root both sides. Remember, we can take the square root of a negative. We just have to write that it's an imaginary number. So we have x minus 1 is equal to the plus or minus the square root of negative 1 over 7. Remember, a negative under a radical is an imaginary. So we want to remember that it's imaginary, and then also remember that we have a radical over a radical. So if I isolated the x, I would get 1 plus or minus I root 1 over root 7. In math, we can't have radicals on the denominator of a fraction, so we would need to maybe show some side work. I have the square root of 1 divided by the square root of 7. Got to rationalize that denominator by multiplying root 7 over root 7, and I would get root 7 over 7. So my final answer in set notation is going to be 1 plus or minus I root 7 over 7. And we're done. Folks, that's the lesson at its finest. Have a great day.